Good morning. How was the party last night? I see a few sleepy faces. I couldn't go because I was preparing for this talk to make sure everything goes smoothly for us today, but I'm glad you guys had fun. How many of you have used mobile services before? Let's see, okay. How many of you would say you're an expert at mobile services? You have to raise your hand, yeah, okay, great. I was going to start with saying that this is an introduction to mobile services. If you're a real expert, if you've built an app with mobile services and you're already published to the store, there are plenty of other talks happening at this slot for you. This might be a little bit kind of an introduction and not advanced. So if you're one of those advanced users, you might consider going to another talk at this slot. I just want to respect your time here at Build. You're not going to hurt my feelings if you go and try out something else. All right, so my name is Yavor. I'm a program manager on the Windows Azure team, and I work on mobile services. And that's the reason why we're here today. We want to learn how to build these connected apps very easily, how to take the pain out of building connected apps. The way we're going to go through today is we're going to split it up kind of in three big chunks and address kind of the three big pillars for mobile services. First, we're going to talk about data, storing server data in the cloud. Then we're going to talk about authentication. How do you set up authentication easily on the client and on the server? And then we're going to talk about push notifications in the end, because that's usually the flashiest part of my demos. So great, I'm excited to have you guys here. Appreciate you made it in at 9 a.m. So let's go ahead and get started. When we talk about mobile services, we always say, what's the key thing about mobile services? And it really is to empower you to build these cloud backends, to connect your apps very easily without needing to write any server code unless you want to. Now, there comes a time when you do need to write server code, or if you're a server developer, you'd like to extend your Azure backend, and you can do that. But getting started is simple, and you don't need to write server code just to get started. And so we talk about connected apps, but what is a connected app? I was reading the news the other day, and I saw this. So you guys have heard of Snapchat? How many of you have heard of Snapchat? It's a cool new app, and they just picked up $60 million additional funding. So what it enables you to do is to take a picture and send it to your friends. And the trick is the picture is short-lived. So after, I think, about 5 or 6 seconds, it actually goes ahead and disappears, and it gets deleted from the Snapchat backend. It gets deleted from your friends' devices. So it's good if you want to send stuff, but you're not too sure. You don't want it to end up all over the internet later on. So it's like a nice way to privately share images. So this came out on Monday, and I decided, why don't we challenge ourselves today? And I want to challenge myself as well. So I said, let's build Snapchat using mobile services in an hour. So by the end of this, we have about 60 people here, and I have 60 new millionaires, right, walking out of the session. So I think it'll be great. So let's go ahead and see what we're going to end up building here. Great. So I'm going to go through a simple demo of my Snapchat, which I've called Slapchat because it needed to rhyme and couldn't think of anything better. So I'm going to open it up. And the first thing, obviously, there's a camera, so I can take pictures with. So that's just standard control. Then I have my list of friends here. So you'll notice Nora is my girlfriend's name, and you actually can't really see very well there. But yeah, basically you see there's basically 2 names in that list, mine and my girlfriend's. So how did that information get populated? Well, we integrate with the phone hub, the phone people hub. So kind of that device integration is something that we've made easy. Then, so let's go ahead and pick one of us, pick myself here. And it's a little bit easier to read now. And I don't have any friends, so let's go to the people hub and find me a friend. And I only have my girlfriend in People Hub, so she's going to become my only friend. And if I log in as her, I'm going to add myself as her only friend. So just to keep things very simple here. And now it's all set up. Let's go and actually look at our pictures here. We don't have anything, right? I haven't sent anything yet, so that's expected. Let's go and send a picture. So I'll hold my phone up and just tap the screen. Okay, so here's my photo, and I'm logged in as Nora. Like when I switched on that in that list box, I'm actually kind of pretending to be logged in as one user or the other, just to make things simple. So I got my my photo taken here, so let's go ahead and send it. And I get thrown over to my photo screen. You see kind of a record of what I just sent. So it's sent by Nora because I'm logged in as her. And I've captured the date when it was sent, so it's sent 9:05 a.m., which is about right. So now let's go and pretend to be me. So I'm going to switch from Nora to me as the logged in user. And I'm going to go look at my photos. You notice there's a new envelope waiting for me. And it's coming from her, so I'm going to go ahead and tap it to open. Pulls up the picture I just took, and this is coming from the cloud. And because it's Snapchat, you notice 6 seconds later it's gone, right? And that's kind of the whole gimmick of this app is it's short-lived. So if I try to open it again and tap it, no luck, right? It's been deleted from the cloud and it's been deleted from my backend. I only have this sort of little record here that says you received it. It was sent at 9:05. You received it at 9:06. It's gone. So we showed integration with the people hub. We showed server data. We showed server logic, basically being able to intelligently reason about when something arrived and when things should be deleted, how long objects should live in the server. So that's kind of another value prop of mobile services. And the last thing I want to touch on is push notifications, right? No app these days is complete without push notifications. So I'm just going to bring up the emulator here on my machine and just send a new picture and trigger a notification. And sure enough, you see here at the top, we got the little notification bar with the toast I just sent. So kind of the three key things that we made very easy, right? Server data, identity, and push. Right, so this is what we're going to go ahead and build in the next hour. Like I mentioned, mobile services provides this easy way, to do kind of these set of core scenarios. It provides kind of a consistent API surface area across all of them, and a one-stop shop management experience for you in the portal. So kind of bridges all of these capabilities together to make things really easy and productive for you as a developer. When we talk about mobile services, we like to think of simplicity and enablement. And I like to bring up these two Legos. So on the left, you see kind of the toy car where somebody took all the pieces out of the box and followed the manual exactly and put it together exactly as intended. They had a productive experience. They were finished in a finite amount of time. They didn't have to pick and choose too many things, and they got exactly what they wanted. So we definitely want to cater to that developer, make that very easy. But we also don't want to close the door to a different kind of developer who after he's built the car, he kind of breaks it apart, takes all the pieces and puts them together into something completely different. And I have no idea what that is, but like a beach home or something. So we also want to enable that kind of developer to go ahead and extend. Once they're done with a simple thing that took them 5 minutes, we want them to be able to keep building. So simplicity with enablement. You heard in Satya's keynote yesterday that we announced general availability for mobile services. So that's pretty exciting. And our GA comes with a very rich feature set. You'll notice right at the top, we support all the major client platforms that are out there today. So you can write for Windows, you can write for Windows Phone, which is what we're here to learn about today. But we also support Android, iOS, and even HTML if you want to embed your mobile service as part of a website. So you can use mobile services for a cross-platform solution. Just because you wrote your first app for Windows Phone doesn't mean you can't then later go ahead and add iOS if you like that. And it's the same backend. You don't have to recreate your backend. You don't have to rewrite your server logic. We enable authentication and authorization very easily with all the big auth providers that are out there, including Facebook, Twitter, Microsoft account. So I'll show login with Microsoft account because that's what works most seamlessly on Windows Phone, but the other ones are available for you as well. We support push notifications, like I showed you. I showed MPNS for the phone, but you can also use WNS. You can use APNS for Apple, GCM for Google devices, Android devices. We also support notification hubs, which is a cool Azure feature, which lets you actually push to a single destination and have the notification delivered across a variety of devices. And they don't have to even be the same kind of device. They can be from different manufacturers. We support scheduled tasks. So if you want to have a periodic process running in your backend, cleaning up some data, we definitely support that. All our backend scripting is in JavaScript, and you use Node.js to write these server scripts. Now, I realize that might be somewhat of a departure for a lot of you who are used to maybe writing your backend logic in .NET. But Node is not scary. It's picking up steam in the community. It's becoming quickly kind of one of the go-to technologies, kind of in developers' toolkit. So it's not something you should be afraid of. You can easily go ahead and get your first script started. And it has a great ecosystem. So there's a lot of people contributing additional modules to Node. So it's quickly becoming as rich as what you would expect in a .NET application. One new thing we added is custom APIs, and you saw that demoed, I believe, in the keynote yesterday, which is normally we're all about data. We're all about sort of CRUD operations on data. Now we allow you to just create an arbitrary HTTP API. So it doesn't have to be tied to a table. It can even not touch your database at all if that's what your application calls for. And I'll show you some examples in my demo. We announced yesterday also our support for source control through Git. So now we have two places where you can author and edit your scripts. You can go to the Azure portal and type your script in there, or you can basically do a Git clone. And for those of you that are not familiar, Git is a distributed source control system. So you can go ahead and use Git to push updates to your scripts. And I guess the third thing that I don't mention on the slide is that you can also use Visual Studio as well, and you saw that in the keynote yesterday. Last but not least, we're integrated with the Azure Store, so it's very easy for you to add third-party services. So if you'd like to send text messages from your server backend, you can just pull in Twilio through the Azure Store. There's a single billing relationship, so you don't get a separate bill from them, and you can use them from within your mobile services server scripts. It's probably one of my last slides, and then we're going to jump into the demo. But as part of kind of that getting started experience, making the simple things really simple in the first 5 minutes, we really want to bet on very good developer documentation. So we have a rich dev center on windowsazure.com/mobile, where you can kind of pivot on your favorite platform. So in this case, you can pivot on Windows Phone, and we have kind of the key scenarios implemented for all the platforms, kind of tailored to your needs. So it's a great resource to get started. Another nice thing is that we have all our source code up on GitHub, which is kind of a commitment that Windows Azure has made across the board to open development. If you go over to our repository, you'll notice that we make daily check-ins into that repository. And if you look at the issue tracker, you'll notice we actually file all the bugs that customers report in the public, in the open. So it's kind of a new thing for us, but I think it's really paying off because you can see as we do daily development and as we fix issues, you can get almost daily feedback as to what's happening with the product. And also, an even better thing is that we actually accept contributions. So if for some reason our team is sitting on the bug that's blocking your application and you really want to get that fixed, you can actually send us a pull request with the fix, and I'll review it, or Paul, one of the other PMs on my team, is going to review it. And if the fix is right, we're just going to merge it in, and you become a contributor to the Windows Azure platform. So that's pretty cool and very exciting for us. And we were so excited that we decided to give everybody 10 free mobile services. Well, you guys are new to mobile services. You always get 10 for free. It's not a, yeah, okay. But there's a car for you. So if you this is a new thing. If you have an MSDN subscription and you haven't activated your Windows Azure benefit, if you go ahead and do that while this promotion is running, you can win an Aston Martin. So that's pretty nice. The second thing is actually true. All right, so enough slides. Let's go ahead and start building our Slack chat application. Right, so I'll start off in Visual Studio, and like all good demos, this is slightly faked. I have the UI implemented already to make getting started very easy. So let me just do kind of one little tweak here before we jump in. Okay, so let's look at the project structure here. You'll notice I've tried to kind of observe. I've tried to be a good citizen of the Windows Phone ecosystem, and I've tried to do my MVVM right, which is new to me. So I have my views and my view models separated out, so you'll notice kind of the view models that back my views here. Just zoom in for you guys. And then I've tried to externalize all the web services interactions, all the mobile services interactions, just so that doesn't get jumbled up in my view models. So you'll notice under here I have a separate project called Snapchat.model, and as part of that project, I have all my data types that are going to back my mobile service, and I also have kind of my services defined. I have a iChat service, which is where I store my messages. I have an iNotification service, which is where I send push notifications. And then I have the iAuthentication service, which I use for auth. You guys are seeing the right? Okay, sorry. Okay, great. So that's kind of how I structured my project. And now, if you look at this model project, right, a good practice is for us to actually port our model across a variety of different applications, right? So we don't want to have to write a specific model for Windows Phone or a specific model for a Windows 8 app. So I've actually used the portable class library here. If I go ahead and open the project properties here, you'll notice that I can actually use the same model code for a Windows Store app or even for a .NET application. So that's been kind of a design principle. Is I've tried to keep all my mobile services stuff in this portable project, so I can then very easily reuse it if I decide to build a Windows Store version of my app. Great. So this is a client-only app. Let's go ahead and run it. And you'll notice that everything will just be in memory. I'm going to use the emulator here. The app comes up. If I go here, see my friends, I can go ahead and add new friends from the People Hub, as I did before. Or hopefully that will work. Yep. And then I have, again, the same sort of screen. We can go ahead and send a message. I get the same kind of functionality I showed you before, but now if I close the app and I reopen it, all that will be gone because this is just my kind of client app, which I use as a starting point. So if I go and I don't have any friends, and all the messages are gone. So the reason why is that is because the service I use to back all my Azure data. So this is this iChat service. I used a local implementation of it. So you notice, here's where I get my friends. Here's where I get all the photo records. Here's where I get all the photo contents. This is how I bring in all my server data. And I used a local implementation of that. So as part of my client project here, you'll see I have this chat service implementation. Basically, it uses a bunch of in-memory dictionaries and arrays and things like that. And that's where this first part of the demo stores its data. Now we're going to go and replace this, right? That's the goal. Is we're going to write a connected chat service that takes all that stuff that I'm now storing in memory and move it to the cloud. Great. So the first thing to connect to the cloud, what do we need to do? We need to we need the API to work with. So I need to add a reference to the Mobile Services SDK to my project. So if I go inside my model here. I can manage the NuGet references. And you notice I've already added a reference to the Mobile Services SDK. One thing that's pretty obvious looking at this screen is that we're not kind of a single bundled up package. Actually, we've kind of embraced the ecosystem, and we've taken dependency on a lot of community packages out there and some Microsoft ones. We don't have our own JSON serialization stack to serialize objects on the wire. We're just using JSON.NET. We're not writing our own HTTP stack. We're using the HTTP client that was released by the BCL team. So we're kind of trying to stay modular, trying to stay as decoupled as possible. So there's no magic in the way our API works. Presumably you understand JSON.NET and HTTP client, and that's why you know how our API works as well. There's no kind of hidden stuff there. So the first thing I did was kind of add a reference to the NuGet SDK. The next thing I need to do is kind of add some connection information to for the cloud, right? How does my project know where to talk to? So I have this mobile services config a file here, which I've used to kind of centralize all my secrets in one place and make sure I don't check them in by mistake. So I have the URI to my mobile service, the application key, and a bunch of other connection settings. Okay, great. Well, where did this come from? And so for that, we have to hop over to the Windows Azure portal. Right. So here's my mobile service. I pre-created it, but you can create one very easily. You just go compute mobile services create. It's a very simple two-step wizard. And then when you're done, you end up with a mobile service just like this one. And if you go over here to the right to the quick glance pane, you'll notice kind of you have the URL you need to connect to the mobile service. And also if you click on manage keys, you get the application key you need. And that's what I use to embed in my application. So that's how I connected my app to the cloud. All right, so then we sorted out our connection to the cloud. Now let's look at our data types, right? So how are we sending this data to the cloud? Well, you noticed I create user registration. So here's my little user object here. I have a name, a user ID, an email address, and then MPNS channel, which I'm going to use later for the push notifications. But pretty simple C# objects with some JSON.NET attributes to lowercase the properties, because that's what I prefer. If you want to leave them uppercase, that's fine as well. So I have a user object. I have a photo record, which is kind of the permanent thing that stays in the system that says so-and-so sent you a message, and it contains this picture. The picture itself gets deleted, but we want to just have this historical list of records of things that were sent. So I have the sender ID, the sender name, the recipient ID, when it was sent, when it was received, things like that. Here's the photo content. So this is the secret bit. This is my object that encapsulates the link to the image, and this is what gets deleted after 6 seconds. So these sit on the server, and the moment you look at them, it's kind of like the Heisenberg cat. Like the moment you look at them, they disappear in 6 seconds. So it has the kind of the secret ID, so only the person that got it can see it. The URI to the actual image, and then the ID that maps it to the photo record. So it's kind of a one-to-one mapping between a photo record and a photo content. Okay, so that's kind of my model that I'm going to use. So let's go and look at a few simple operations. So I'm going to open my connected chat service, which is the implementation of iChat service that actually uses Azure. And let me also just open the client-only one so we can kind of go back and forth and compare. So you'll notice kind of here are my in-memory dictionaries and arrays, and those have been replaced by a bunch of tables in Azure. So you see the users table, contents table, records table. These kind of correspond to the objects you saw in my data model. So the first thing we do is we new up a mobile service client, and that came from that NuGet reference with the secrets that I provided in the config file. And then I just get references to my tables. So here's my photo contents table, here's my photo records table, here's my users table. Pretty straightforward. Let's look at how do we create a user. So when I go to that friends screen and I tap on a user where I fake kind of logging in, this insert method gets called to make sure that there's a user already registered for that live ID. So if I look at my client-only implementation here, here's my kind of implementation of create user. I go against this users array and I say, okay, is there an ID? Is this user already in your little collection? If it is, return me that user and update him. If not, let's go ahead and create a new user. And then I do kind of this unwrapping of the emails. So this is kind of like a navigation property. Because I want to be able to have people connect through their email addresses. Someone can have multiple email addresses. So when I register the user, I take a note of all of their email addresses that they had in People Hub. and I send it up to my Azure backend, I kind of explode it out in a separate table, mapping email addresses to the user ID. So now I have an easy lookup when someone says, I want to friend this particular email address. I can go to my table where I've exploded all the email addresses and look it up and easily map which email address corresponds to which user ID. So this is my kind of poor man's way of doing kind of the friend graph, but I'm using the email addresses as the keys. So you notice here I have kind of a separate array for email addresses, and I kind of explode them. I split the string that I sent, and I explode it out and add a record, a mapping to the user ID for each email address. You'll notice that's turned into just a single call on the client, just insert. Okay, well, so let's go and, like, where did that logic go, right? Like, where does all this happen, what I just showed you? So for that, we're going to navigate back to the portal. And I'll go to the data tab here, and this is where you'll notice all these tables, right? So here's the users table that we're working with, and there's a correspondence between the tables you saw here, my client code, the users, photo content, photo record. They're all here: users, photo content, photo record, plus a bunch of other ones. So remember, we're doing insert into the users table. So let's go to our little script tab, and this is where you write your server logic if you want. You can omit this completely and not have any server logic, but in my case, I need it. So you'll notice I go ahead and let me first talk about kind of what you see here. So the shape of all of our server scripts is pretty much the same. It's kind of the verb you're using, so like insert, update, read, delete. And then it takes a few parameters. Item is the thing that the user sent in over the wire. User is an object we use for authentication, which I'm going to talk about later. And then a request is the incoming HTTP request in case you want to parse some extra headers off of it, or or query strings or things like that. And then somewhere in every script, you want to call eventually request.execute. So you can do logic kind of before you execute the request, and you can do logic after you execute the request. And executing the request just means perform the database operation. So this is an insert. So when I call request.execute, what that means is the script goes ahead and inserts that item object that came from the wire. So that's kind of the general structure. Let's go through this particular script. You notice I start with querying the users table. So I say, well, OK, do I have an existing user? And you notice our query format is you can just pass a JSON object here and say, OK, is there a user ID corresponding to this user ID? So let me look up this particular user. And then to the read object, you pass another object with two properties, success and error. And so success basically is the function that's going to get called if the lookup succeeds, and the results here are going to be mapped to this property, to the results property. OK, so then based on the results, I look at the result, and if the result exists, right, if its me property is set, that means that there was already a record for that user, in which case this is kind of the else here. I'll go ahead and I'll update it. I'll make sure the name is correct. I'll make sure the channel is correct, the email addresses, all of that. If there wasn't, I'll create a new one. So I'll just say request.execute, which will go ahead and insert the item into my table. And then you notice this extract email addresses method, and that's actually kind of implemented further down on the page here. This is where I do that magic to kind of explode out the email addresses into their own table. So I'm kind of faking navigation properties, since those are they're not supported out of the box. Here's the reference to my emails table, which I've created here, and the emails is just a mapping between email address and user ID. So I'll go ahead and basically split them out, and for each email address, first I'll pull it up if it's there, and then if it's there, I'll update it with the right user ID. If it's not there, I'll just insert a new record, so it's just an email address mapping to a user ID. And the reason why I'm kind of going through this script, I know it's kind of specific to my app. It's probably not super useful outside this context, but it gives you an idea of what these scripts kind of look like. Great, so we went through the insert script. Now, the next step after I create a user is to add friends, right? You saw me press that button that says invite my people hub friends. So let's go back to our service here. You'll see I have kind of this create friends method here. And before, again, it used to do some client-side stuff. Now it uses this invoke API method to call something called create friends. And now this is slightly different, right? At this point, I'm not going against an individual table and doing like an insert or a read. Create friends is kind of a complicated process. It takes multiple steps and touches multiple tables, so it didn't really make sense to do it as an insert script or anything like that. It's just kind of not the right place for it. So I just created a HTTP API for that operation. So let's go ahead back to the portal, and I'll show you the area where you find these. So the scripts for your data tables are stored here under the Data tab. The scripts for custom APIs are just stored in this new API tab. So you notice here, here's my create friends custom API. I can set permissions on the individual operations, HTTP operations, but I'll save that for later. Here's the actual script, right? And so the shape is a little bit different because I have to indicate is it a HTTP post or HTTP get. So here I'm saying it's a post. And then I pull up a bunch of the properties from the request object, like here's the email addresses that he's trying of the people he's trying to friend, and then here's the reference to the friends table. The friends table is just a one-to-one mapping between user ID. So this way it's kind of my join table between users and friends. This way I know who's friends with who. The next line here is a little bit different. So what I'm trying to do here is do kind of a subquery. And our simple table API that I showed you before, where we say table.where, that doesn't necessarily lend itself very well to these kind of complicated SQL operations. So we let you drop down to raw SQL if that's what your operation needs. And I could have written a bunch of code using our table API to achieve the same effect. But this is much simpler. I can just drop down to SQL, and I'm going to read this backwards actually. So I take my list of email addresses, I turn it into kind of a SQL array, and I say, okay, go to this emails table, pull up all the user IDs for these email addresses. So that's the first part of the query. Now I have an array of user IDs by the time this query is done. Then I go in my users table and say, okay, now look up the users corresponding to these user IDs. So this is kind of like in 3 lines, I kind of traverse these 3 tables to do kind of a correlation. Email address to user ID to user object. So as a result, basically, this create friends is going to return an array of friends down here. So when the SQL query succeeds, you'll see this friends property of my callback is going to get populated. I insert them into my friends table, and then I return them. So that's kind of another thing I wanted to highlight. This is kind of that escape hatch that I talked about, kind of the extensibility. If our simple table API doesn't give you what you want, you can still drop to raw SQL and do things that way as well. Okay. One thing I also want to touch on is, so far I've been going in the portal and editing the scripts. I mentioned we support source control, so you can use Git to edit your scripts as well. So normally I'm here in the dashboard, and before I set up Git, there was a create Git credentials link here, and then when I click it, it turns into reset. So I've already set up Git for my mobile service. And then I went ahead and cloned it here locally, so I just did git clone and used the URL of the mobile service. And then let's go ahead and, I've made some changes in the portal since I last cloned it, so we can do a git pull. It's going to go ahead and talk to Azure and pull down all my scripts, any updates to my scripts that I have locally. And this sometimes takes a few minutes. Oh, it turns out I'm already up to date. Okay, so let's see what we have in here. So we have a kind of a service folder and a bunch of subfolders like API, scheduler, shared, table. Let's go inside API. You'll see we have scripts that correspond to everything that I've been editing in the portal. So you have create friends, read friends. So I can go ahead and open that up, and sure enough, it will be the same thing we were just looking at in the portal. Sorry. Yeah, it's in the same script we were just looking at the portal. And I can go ahead and make changes here, check in, and then just do git commit, git push to get them into Azure. We're kind of short on time, so I'm not going to go through that. I showed you custom API. I showed you the kind of the different tables I have here. Let's go to kind of the meat of the app, which is the piece of logic that goes ahead and deletes things after they've been seen, right? So that's going to be in this photo contents table. And that's the read script for the contents table, right? Because we want the first time they read it, we want to delete it after 6 seconds. So let's go ahead and find the read script here. And you'll notice, okay, so I let the read complete. So I call request to execute. I say, okay, return them what they're trying to get. And then I'll go and I'll take the actual result. So this is what the contents that they requested, the contents object. And then I'll go in the photo record table, I'll update the received time and things like that, right? So remember we have the content and the record wants to remember when they looked at the record wants to know when they looked at the content. So I'll mark received on the record, I'll update it, and then I'll call this delete content function. So I'll go against my records table, and this is after 6 seconds. You'll notice I have this set timeout call here, so that's a kind of a Node.js way to say, do something after 500 milliseconds. So 5 seconds later, delete content will get called, and then I'll set this expired property on the record. So this way, when I query, I can see which ones have already been read based on this expired property, and then once that's set correctly, I'll just say contents table.delete content. So this is kind of the richness of this server scripting model, right? This is where my app works. It's kind of this core logic that I needed some place for that to live. It can be on the client, right? Because then people can game my app, so it needs to be on the server. So this one method is kind of the heart of my app. If the images don't delete, then I've kind of lost my gimmick, right? That's what my whole app is about. And in just about 100 lines of server script here, I have that working. Great. So we spent enough time on kind of the data model, working with tables, working with scripts, working with custom APIs. Let's go ahead and hop over back to the slides for a minute here. And we're going to shift gears. We talked about data. Now it's time to talk a little bit about auth. And when it comes to authentication, we try to make it very easy, but we still support 2 different models that let you kind of do things slightly differently, depending on what your goal is. So we support the auth providers I already mentioned, and then in the server flow, it's just meant to be drop dead simple. So we let you log in on the client, you type in your credentials, we open up a little web view control, and so we navigate to the auth provider's login page. Let you sign in the browser. That gives the auth provider your credentials. Then the auth provider is going to get back to mobile services and send us the authentication token. So now mobile services knows who you are on the server, and then we'll send you back the authentication token. So now you have the user's identity both on the client and on the server. So you have this user ID property you can now use to authorize people on the server and to authenticate them on the client. So that's kind of very, very simple. The downside of that is that because you don't see the auth token directly in your application, your ability to work with the graph for that particular auth provider is pretty limited. So if you want to go after you've authenticated the user, that token will contain maybe their user ID and their name. That's probably it. But that token might give you permission to access more, like their friends and their photos on Facebook and things like that. So with this method, you can get some of that on the server, but it's not quite as rich. We support another a flow which we call the client flow, which uses the device-specific SDK from the auth providers. So in this case, you're using the Live Connect SDK, which is specifically for Windows Phone or specifically for Windows 8. Or on the iPhone, you can use the Facebook single sign-on thing. They have a SDK that lets you natively sign on just stay signed on your iPhone. So the benefit of that is obviously, it's probably a little bit more polished. The experience is a little bit more polished on the client. And like I mentioned, some of them support single sign-on. Windows 8 also supports single sign-on if you use the Live SDK. It's a little bit more work to set it up, though, because then you have to reference that particular SDK into your project. You need to figure out what's the code you need to write to get that to work. So it's a little bit more work to use the client flow. So you pass the credentials to the auth provider, and this is going to be through whatever UI the auth provider has selected. So when you use the Windows 8 SDK, it opens the built-in Windows 8 stuff. Like mobile service doesn't control that. then so that auth provider sends you back your auth token and you get it in your own app. No mobile services so far. Now you can take that auth token and send it to us to now authenticate you on the server as well, right? And there's a little trick here where there's a shared secret between the auth provider, like Facebook, and mobile services for that handshake to work. So we know we can trust that auth token that we just received from the client. So there's a signature we can check with that shared key to make sure this actually came from Facebook. This actually was signed by Facebook for that particular app. The beauty of this now is that you get much fuller graph access, because on the first arrow, when you asked for when you logged in and you provided your credentials, you as a developer, you control what tokens what scopes you want to request for that token. So if you want to say I want not only their identity, but I want photos, I want friend graph, I want to know when their birthday is. I want to be able to access it anytime. I want to expire 3 years from now. You can request all those things in the token you send yourself in kind of the first leg of the auth flow. So it gives you a little bit richer graph access. So just to recap, the server flow, very easy, uses this web view control with just a OAuth flow inside of it. Very easy to get started. Not as rich when it comes to graph access. Not as rich when it comes to single sign-on and things like that. Client flow, a little bit harder to set up, gives you single sign-on, and it lets you get more of the graph. So let's go ahead and demo these in the context of my app here. Now, I've faked it a little bit, right, because a lot of my demo required to go ahead and kind of log in as one user so I can see the messages that was sent to me and then log in as the other user to send a message. So I had to kind of hack around auth a little bit here, but I can kind of go through the steps I would go through as a developer to properly configure authentication for my app. The first thing I'm going to do is actually head on to the Live Connect Developer Center. And that's where I configure that shared secret that I talked about, right? When we receive a token from an authentication provider, mobile services needs to be able to validate that token to be sure it actually came from the auth provider. Because someone in the middle could be intercepting it, could be changing it, or the client could have stolen somebody else's token, so we want to prevent against that. And the way you do that is you create an app here in the Live Connect Dev Center. And then when your user logs in, they log into that particular app. We know what the secret is for that app. So in this particular case, you'll see this client secret property here. That's the secret that's going to be shared between the auth provider and mobile services to make sure the token is authentic. So I registered my app here. I need this piece of information, the client secret. Then I hop over to my mobile services portal, and you notice we have an identity tab. And this is where I configure the different auth providers, and you'll notice all of them have this exact same scheme, with minor variations, but all of them require some shared piece between the auth provider and mobile services. So here's where I pasted the token that came from Live Connect. Facebook has the exact same method, basically an app ID and then an app secret. So does Twitter. So does Google. So it's very, very much symmetric. When you configure these, it's kind of just, yeah, okay, I got to find the secret, copy, paste it in the right place. But with that, I'm basically all set up on my server to validate the token. Let's go ahead and see how we obtain the token on the client. So in this particular example, I'll show you actually both the client flow and the server flow. And on the phone, unfortunately, the difference isn't that significant. I'll show them to you anyway. So I do this in my friends view model, which is probably not the right place to do it. So somewhere down here. All right. So here's where I kind of fake the auth. So I'm going to get rid of this fake auth here, and I'm going to bring in my real authenticate method. Here's my authenticate implementation, and you'll notice it uses the provider-specific, phone-specific SDK. So this is a Live Connect SDK for Windows Phone, which is different from the Live Connect SDK for Windows 8. The The code is the same, but it's a different assembly you have to reference. And this is all boilerplate code straight from their portal and their developer center. There's nothing mobile services related here. I'll go ahead and I'll say login async. That'll bring up their auth UI. And then when I get logged in correctly, you'll see basically this session property is going to, actually let me scroll over here. This session property is going to have an authentication token property, and that's where I get that token back. Now that's the token the mobile services cares about. That's what I want to send in. So then you'll call, and here again you have to go through my abstractions. So authentication service is what I use to wrap my calls. So login async will actually call login with Microsoft account async. So this is the method you use to pass the token from the Live Connect SDK to the mobile services client to send to the server. I know it's a little bit, kind of strange and hard to follow, but I did try to follow best practices and do services and all of that. So basically, this is the call on our SDK that you need to make and then pass in the token. And the token came from the Live Connect session. Then when I'm logged in the mobile services backend, it's going to return this user object. And the user object has some properties on it, like you'll notice it has the user ID. So that's kind of the important property I can use to authorize users. But it doesn't have that much else, actually. It doesn't have the name or like if I want any of their, contact information or email addresses. It's a very simple token. So you notice here I open this Live Connect client, and that's again part of the Live Connect SDK. And I use the same token that they gave me to go up against now the live graph and ask for a bunch more stuff. So I say, okay, get me the me object. And the me object in this case has things like the first name, last name, date of birth, email addresses. So this is kind of what I was saying, right? When you're holding the auth token by using this client flow, now you can use the provider-specific API to go and get more information about the user. So in this case, I use the user ID and then the name I use from the Microsoft account from their graph to populate my local user object. So that was kind of the hard, the hard way, but it gives you a little bit more bells and whistles. Let's go ahead and actually run this. I think I need to add async here. Oh, I already do. Okay, great. So hopefully this will work. All right, so going to my little friends screen here, brings up the auth UI from Microsoft account. I can go ahead and sign in here. And then everything else will work. In the interest of time, I'm actually not going to go through that, but I'll show you the other flow, the server flow, which is just drop dead simple. So let's go ahead. Let's go ahead and get rid of this authenticate method. Just get rid of it, and then I'll just substitute this much simpler authenticate method that I wrote. So I call this login easy async is what I called it in my service. Let's go and see the actual implementation. It's just as simple. Instead of calling login with Microsoft account and passing the token, I just call login async, and I pass which provider I want to log in with. So this is kind of the difference. The first method is what I use for that client flow, passing the token I got from the Live SDK. The second method is just, okay, mobile services, go log me in. Log me in with Microsoft account. I don't care about anything else. And this works just as well. So I've switched this to just use login easy async. And then let's go ahead and run it. Go to my friends page. Again, I get an auth UI. Slightly different. This one is actually the website rehosted inside that web view. Kind of the same result, but a little bit simpler to write on the client. The downside, of course, is that now I don't have the authentication token handy, so I don't know the name of the user. So kind of I traded some of that simplicity. I traded some features for that. So it depends on what your goal is, right? If you just want to authenticate them quickly, this is plenty. If you wanted to do richer graph access, use the client flow. Now, this was the server bit, right? So now I'm logged in. I'm logged in on the client. Now, what do I do on the server to log in on the server as well? I call that login async method, you noticed. So then I pass the token in. So now I have that token on the server. But how do I make authentication decisions based on that token? The first thing I can do is kind of very coarse-grained. So I can go inside my table here. Let's say users table. And I can go into this permissions tab. And I can make very coarse-grained authorization decisions. So in this case, I've said, anybody with an application key can insert, update, delete users in this table, which is basically everybody who uses my app, not even just authenticated users. And that's clearly not the right setting. So we want to set only scripts and admins for basically all of these. And only scripts and admins means basically only people using the portal and only scripts that are, that's an interesting bug, I can't actually select. Okay. Only people that are using the portal and only my scripts written in the portal, but I control both of these as a developer, so only those can access this table. The insert script is the one that my app actually calls to register a user. So for this, I'll select only authenticated users. And this way, mobile services will make sure login async was called first, and I was passed a valid auth token first before someone attempts to call this method. So this is kind of very coarse, like method level or script level authorization. I want maybe something more fine-grained, right? Maybe I want inside my actual method to make some authorization decisions. So let's go inside the photo records table, and then go inside the read script there. Now, this is kind of an important part of my app, right? I want to make sure when somebody's browsing this photo records table, I want them to only be able to see the photos that were sent by them or sent to them, right? I don't want them to just be able to see anybody else's photos. So this is where I use that user object, right? So the user object is kind of the verified identity of the logged in user, verified using the auth token. So in this particular case, it'll have a user ID property, which is the user ID of the logged in user. Normally, I can get it from the user can also send me the user ID, either in the object they're trying to insert or as a parameter, but I don't want to trust that ever because they can just be lying, right? I want to always double check and make sure that the user ID they're giving me is the one that they've logged in the server with. So here I used to, this was my very naive way to get this to work, is I would say user ID just comes from whatever the user sent. That's clearly not right if I want to do auth. So the user ID needs to come from the user object. And then I can make an authorization decision based on it. So in my query here, I'll say, OK, only return results where the sender user ID or the recipient user ID is the user ID of the logged in user. Great. I have very little time left, so we're going to quickly mosey over to the push part of the talk. So we talked about auth. Let's talk about push. Again, for push, we have two choices for you because we want to keep everything simple. You can use the native device push, and this is MPNS like you've seen it before, or WNS. It's exactly the same kind of thing. So first you go and you register a channel using their API. You get your channel back to the client. Then you send it to mobile services to stash away, saying, OK, this is my channel in case you want to call me. And then at some point, mobile services might want to call you, so they'll look up your channel and go to MPNS and say, OK, MPNS, here's the channel I want to talk to. Send them this notification. That's pretty standard. That's how you probably use MPNS today, except instead of using mobile services, maybe you have your own backend or something like that. Mobile services makes that backend very easy. I'm going to go ahead and show you. We have right, and you received the message, obviously. We have another approach which works much better at scale. So in the previous approach, you notice I have to store all the channels myself in my mobile service backend. And if I want to send a notification to every single channel, I have to go inside that table and now go row by row by row and send an individual push to MPNS for every user in that table. And that doesn't scale if you want to send like a notification to all your app users. So notification hubs is an Azure feature that makes that scenario very easy. And They have preview support for MPNS right now, and so you can basically register for MPNS like you would normally, but then instead of sending your mobile services your channel, you actually send it to Notification Hub, and Notification Hubs is kind of the record keeper for all the channels. And the way you label your channel is by a tag. So you'll say, okay, I want to get news for this particular app. I mean, as the app developer, you say that. When you register a channel, say, okay, like let's name this, let's tag this with, Slapchat in my case. Then it's very easy for the mobile service to send a notification. It sends a single message to the Notification Hub to the given tag it wants to talk to, and the Notification Hub will take care of delivering through the push notification service the notifications to all the devices that are registered for that tag. So that's kind of your solution for doing push at scale. Let's go through kind of first we'll do the simple MPNS push. So for that, I'll just head over to the push tab here. So some of the push services require for you to set up authentication with the push service itself, so that they make sure you don't go and try to DOS somebody's device. They want to know who is sending these pushes. So for example, if you're using WNS, you have to go and register. If you're using Apple, Google, you have to register. For MPNS, they've decided to take a slightly different approach. They've said, okay, anybody can send anybody up to 500 pushes a day. So I don't have to be authenticated to send 500 pushes, which makes my setup here very easy. So I actually don't do anything on the push tab. Then I just go straight to my script and I start sending notifications. So if I go inside my records table, oh shoot, thank you. 6. Okay, so you guys had no idea what I showed. Okay, I was talking about the push tab right here. So here's where we configure WNS, APNS, GCM. MPNS doesn't require any setup here. If I head over to my records, and that's the table where I want to send the push notification. If somebody inserts a new photo record, that means someone needs to be notified. Oh, you have a new photo waiting for you. So if I go here inside the insert script, somewhere down here, after I've done all my logic, you'll see I have a send push notification call. I'll find my method down here that does it. You notice it's very simple. I go to my users table, and you remember I had an MPNS channel property that I used to store the channel. I can show it to you again here. Go to my user object. MPNS channel, and I set it. I'm not going to show you the code. It's boilerplate register for the channel, and I sent it to mobile services right over here. So I pull up basically the channel for each user ID from the users table, and then this is how simple it is to actually call the API. I say send toast, give it the channel, give it the payload, done. Right. So 4 lines to send the push notification. No configuration was necessary. So that's useful if I'm sending pushes to like individual devices. This is going to be very small scale, and I need to make 1 call per device because it's whenever you get a photo, it's kind of asynchronous. You never know when this is going to happen. Now let's talk about the other scenario where I'm sending pushes at scale. Let's say we're having an outage or something, and I want everybody who's using my app to go ahead and know about it. Let's go on the server first. On the client first. Let me show you where I register for that notification hub. If I go inside my model here, I'll open up my notification service. And you notice, I new up the notification hub here. I provide some configuration information. And then I say, OK, register with this particular template. And then I didn't even specify a tag in this case because I'm just sending 1 notification. I didn't have to use tags. I could have used a tag. So I'm saying, OK, send me a notification, and let's use this template when you want to send when I want to receive a notification, send it to me in this particular format. This is nice if you want to maybe change the locale. If you have users in different countries, when you register to the notification hub, you can say, put this in French or something like that. So now I'm registered. Now Notification Hub knows about me. I sent it my channel. And now anybody sending to that hub, I'll receive their messages. let's go and look at the server code to send messages to the hub. I've used the scheduler script here just because it's kind of a gimmick a little bit, and it's part of the demo. So here's my send news schedule script. I could turn this on and it would send news every, once a day or something like that. So here it is. So I again, get a reference to my notification hub, again, provide a connection string, and then I just call send. And I give it, basically the message I want to send to all the devices in that hub. Then, I provide kind of a connection string. This connection string has like kind of a little bit different permissions than the other one. Let's go ahead and run this. I'm going to bring up my app here, and then hit run once. And this device got it. My emulator is not happy. But if we switch over, well, it disappeared. Let me send it again. There you go. Our outage is resolved. So this came from the notification hubs. And I could deliver this just as easily to a whole bunch of devices. All right. That's pretty much it for my talk. I'm going to hold you just 1 minute more. I want to emphasize kind of the cadence on which we've been releasing. We've been shipping features monthly starting August last year. We finally hit GA. But we're definitely not going to stop. We're going to keep going. And we can't talk too much about the features that are coming forward, but kind of the general direction is twofold. One direction we're going to focus on is consumer apps. We want to make like the Coca-Cola app for Windows Phone. We want to make building an app like that extremely simple for agencies and people to build those kinds of apps. The other big direction we're going to focus on is business apps. So if your department decides to do the next expense app using mobile services, we want to enable that very easily. Skip through this. We've seen great traction. You saw in the keynote we have 20,000 apps already, and the number keeps growing. I mean, I looked at our graph today, and it's kind of spiking up right after we went GA. So some great apps. Rowie, which is a very popular Twitter client on Windows 8, is using mobile services to power push. We have a digital health scorecard app by Johnson & Johnson. We have the winter activity app, which is part of the Nokia collection. Actually, the developer is sitting right there. If you want to talk to him, he's using mobile services heavily. It's a beautifully done app. So yeah, I mean, we've had great traction. We want you guys to start building, so just head on over to windowsazure.com/mobile, and I'll take some questions. There's some extra sessions today you might want to consider going to. It's kind of, there's a session right after me about kind of even more specifics about going live. Elio's session, Elio's sitting right here. He's going to talk more about notification hubs. And then Dinesh talking about authentication at 2 p.m., going up against Nick talking about Windows 8 at 2. Thank you very much. And I'll just take